Okay, today we are discussing AtCoder problem number C, AtCoder contest 359. Here you are given a point as x and x, y, and you need to reach the destination at tx and ty. As x and sy is it on a grid. The grid consists of 2 into 1 tiles. You have to move from sx and sy to tx and ty. If you move through the bricks, then you have to pay a toll of 1. If you move within the brick, you don't have to pay any toll. So the questions asks you to find out the minimum toll you need to pay, and you can move in all the 4 different directions. So one small caveat is here, when you say sx sy, actually the position that you start is from sx plus 0.5 and sy plus 0.5. So let's look at an example. Here sx is 5 and sy is 0. So you are actually at position 5, 0, 1, 2, 3, 4, 5, and then that's that 0.5 you want to add. So you are actually at position 5.5 and position 0.5, and you have to go to position 2.5. So actual position you want to go is 2.5, 5.5. So let's see. If you are at this position, if you go to the left, because it's in the same brick, you don't have to pay any toll. But from here, if you go up, then you are crossing into a new brick. So you have to pay a new toll of 1 because you're going to cross over one brick. From here, you're going to the left, which is the same brick, so you don't have to pay any toll. But from here, you're going up by 3 bricks, which means you have to pay a toll of 3 because you're crossing 3 different bricks. And from here, this point, you can go left, which is in the same brick, so you don't have to pay any toll. And finally, from here, if you go up by 1 brick, you are going to a new brick, so the total is 1. The total toll you have to pay is the number of bricks that you need to cross. So here you're crossing 1 brick, here you're crossing 2 brick, 3 brick, 4 brick, and then 5 brick. So totally you're going to pay like 5 as your total toll. Let's look at an example. In this example, your point sx and xy, I'm calling it, let's say P. P can be anywhere in the grid. To identify a unique position of P, what I'm going to do is I'm going to identify where the brick associated with the point P lies. So here the brick associated with point P starts from this point, right? Similarly, if there is a point P2, the point P2 is on the brick which starts at this point. But if the point P3 was here, it also has the same brick which is starting at this point. So now I can say P2 and P3 has the P2 and this is P2 and P3 are in the same brick which is starting at this position. So how do you know what is that position or the starting position of the brick? For that, let's say you have a point P over here. This P is actually 3.5, 2.5. So this is the point P. So you can see x is basically 3 and y is 2. Now, if x and y are not the same, right, the brick will start at this point. This point is basically 2, 2. So if x and y are not the same, then the brick starts at x minus 1, y. So this is the point P, which is at 3, 2. The brick starts at 2, 2. But let's say you were over here. In this case, P is equal to 1.5 and 1.5. So x is equal to 1, y is equal to 1. In this case, x is equal to y. So if x is equal to y, the brick will start at x, y itself. That's a simple criteria to know. If x and y have the same parity, then the brick starts, then the point P lies on the brick at x, y. If x comma y have different values, then the brick starts at position x minus 1, y comma 1, x comma 1 comma y. That's it. Let's say this is the question that is given to you, that you are given sx, sy, and you need to reach tx, ty. Instead of calculating this distance, what I'm going to do is I'm going to subtract the value of sx from tx and the value of sy from ty, so that I can calculate, instead of sx, sy, I can calculate the distance from 0 to tx minus sx and ty, comma ty minus sy. So this distance is basically same as this distance, is what I'm trying to say. That is the second observation. After this is just finally, if you are at position 0, 0 and you want to go to tx, ty, you can see that you have to go at least this ty distance to reach this destination. So from 0, 0, you have to go at least ty distance up to reach this. But let's say your point was over here, then you have to go at least this ty distance to reach this point, and then you have to go at least this d distance. Now this d distance is given by tx minus ty by 2, which is the half of the distance between tx and ty. So you need to go at least this ty distance and then at least this d distance. But in the previous case, we did not calculate the d because we went only ty distance. But here you are calculating d. How would you know when to calculate, when to add this d? So here the total distance was just ty. Here the total distance was including y, which you have to go up by like ty, plus you have to calculate the distance d, which is given by tx minus ty. This d is only added if ty is less than tx. That means here you can see ty is greater than or equal to tx, so d will be equal to 0, and you just have to go only up by the y distance. But here ty is less than tx, so you have to go at least ty, which is this distance, and an additional d, which is given by tx minus ty. So let's look at the solution. So here what I'm doing is I'm inputting the values. Here I'm calculating where the brick lies. So if sx is equal to xy, then the brick lies at sx comma 0. Otherwise, if sx is not equal to sy, then sy and sx are of different parity. So the brick lies at sx minus 1 comma y. So here what I'm doing is, if sx is equal to sy, then the brick lies at sx comma sy, sy, and otherwise the brick lies at sx minus 1 comma y. To check whether sx is equal to xy, I am telling like if sx is equal to sy, then the absolute value of sx comma sy mod 2 will be equal to 0, and the brick lies at sx comma sy. If sx is not equal to sy, then this if sx is not equal to sy, then the absolute value of sx minus sy is not equal to 0, and the brick lies at sx minus 1 comma y. And this is for this is for identifying where the starting location brick lies. This is for identifying where the where the ending location brick lies. Now this will tell you that instead of calculating the distance from distance from Sx, Sy to Tx, Ty, calculate distance from 0 to Tx, Sx and Ty, Sy. That is what this part of the code is doing. Now I want to identify whether to go up by Ty and add distance d, or just go up by Ty distance, and that's what we are calculating over here. So here I am telling that if Tx is greater than Ty, so instead of this, here I'm telling that you have to go at least y distance to go at least Ty distance, add the distance d if Ty is less than Tx. So the distance d I'm calculating as max of 0, Tx minus Ty by 2. This is my d distance. So either Tx minus Ty is going to be negative, in which case this max is going to give you 0, and Tx minus Ty is going to be negative if Tx is less than Ty. But if Tx is greater than Ty, which is what we want over here, Tx is greater than Ty, then the max of 0, Tx minus Ty by 2 will be this value of Tx minus Ty by 2. And that value of d I am adding to Ty to get the answer. That's it.